Hello, welcome to today's lecture. Today we will discuss another new type of bond, that is hydrogen bond. The total lecture is dedicated to hydrogen bond and its properties. So what is hydrogen bond? Initially we already studied covalent bond, ionic bond, metallic bond, and then a type of secondary bond, but very important bond, that is van der Waals bond. Now, what was covalent bond? Covalent bond is a very specific strong bond that took place between the two neighboring atoms by equal sharing or sharing of electrons. Important characteristic of covalent bond is the shared pair of electrons is localized, and hence it is a strong bond with strong directional characteristics. Okay, so it was covalent bond. Now a very specific covalent bond, when it is formed between hydrogen atom and another highly electronegative atom such as oxygen, chlorine, fluorine, etc., then the situation is quite different. In this case, that is when the bond is formed, covalent bond is formed between a hydrogen atom and other electronegative atom such as oxygen, chlorine, fluorine, etc., then the pair of electron that is shared between the atoms will get more attracted towards electronegative atom than the hydrogen atom. So this is the very interesting phenomena that took place when the covalent bond is formed between hydrogen atom and other highly electronegative atoms such as oxygen, chlorine, fluorine, etc. Now why this happens? That the shared pair of electrons get attracted towards the electronegative atom rather than the hydrogen atom. Now, before answering the why, let us see what happens when the electron pair gets attracted towards electronegative atom. When electron pair get attracted towards the electronegative atom, consequently it acquires a negative charge. And what about hydrogen atom? Since there is no electron towards hydrogen atom, it acquires an equal amount of positive charge. Now what has happened is interesting, that we have obtained a molecule whose poles, which has poles, one is negative charge, other is positive charge, separated by a specific distance. That means the molecule formed now is polarized, and this molecule will now behave as a permanent dipole, giving rise to very interesting type of bond. When number of such dipoles, that means the hydrogen side has positive charge and the electronegative atom has negative charge, then it is a permanent dipole, polarized due to transfer of pair, due to attraction of pair towards electronegative atom. And when such number of dipoles get attracted to one another due to Coulombic force of attraction that took place between a negative charge and a positive charge, that means a negative side of one molecule with the positive side of the other molecule, the very specific interaction took place. This interaction between oppositely charged ends of permanently polarized molecules, each containing a hydrogen atom, is called hydrogen bond. Now, in case if hydrogen does not participate in the bond, Since there is no hydrogen but it is a dipolar interaction, the bond will be a dipole bond. It is also a dipole bond, but special importance is to the hydrogen atom. Okay, so what is hydrogen bond? The hydrogen bond is the bond took place due to interaction between oppositely charged ends of permanently polarized molecules, each containing a hydrogen atom, okay, is called hydrogen bond. So, important condition is that the bond that took place between the two polarized molecules with the condition that each molecule has a hydrogen atom. Okay, and when the oppositely charged ends of these permanently polarized molecule forms the bond where the molecule has a hydrogen atom, then the bond is called as hydrogen bond. In absentia of hydrogen, it is a dipole bond. Now, as I have told to you, the special significance is to the attached hydrogen atom to the molecule. Okay, now what is the significance is? If you are looking at the periodic table, you will find that hydrogen is the only element which has a single electron orbiting in its orbit, and there is a single proton, that is a unique positive charge in its nucleus. Now what happens due to this single electron property? When another electronegative molecule came near to hydrogen atom, then the pair of electron get totally attracted towards the electronegative atom, and the site of hydrogen atom is now without a shielding, without the orbiting electron or without the shield of the electron. That means towards the hydrogen site, it is simply a proton fixed to one end of the bond, or bare proton. Okay, bare means without shielding of the electron. There is no negative charge. It is a pure positive charge towards hydrogen site. So this is the special significance attached with the hydrogen atom. Since hydrogen atom has single electron, and after sharing, it is attracted towards the electronegative atom. So what about the hydrogen site? Hydrogen site is simply a proton, that is a positive charge, strong positive charge, pure positive charge. Okay, and which is not surrounded by the electrons. Okay, so it is only the situation that has been created only due to the uniqueness of hydrogen atom, which has a single electron. Okay, so the hydrogen atom has important role in formation of the bond, and hence it is called as hydrogen bond. Now let us for example consider that it is not a hydrogen atom and another atom in the periodic table that participate in the formation of the outer electrons. Then what happens? Since all other atoms except hydrogen has more number of electrons more than one. So though they share a electron, still they have an electron, okay, towards their end, and there is a positive charge, but it is not a charge due to proton. Okay, there is a shielding of electron over the proton. Okay, so it is not a positive nuclear charge. It is a positive charge due to lack of electrons. Okay, so positive end is not truly positive as it is in case of the hydrogen. Okay, so the polarization will be not strong as compared to the hydrogen bond. Now let us see the properties of hydrogen bond. Okay, now before going towards properties of hydrogen atom, let us look at the figure we will discuss here. Now here we will find that 3 water molecules are shown. Now look at the single water molecule. You will find that oxygen is forming a bond or sharing electrons with two hydrogen atoms, and the shared pair of electron is towards oxygen side. So what about towards hydrogen side of two atoms, two hydrogen atoms? It is simply a proton and hence a strong positive charge. On the other hand, towards the other side, that is oxygen side, has full of electrons. Okay, even there are all electrons present towards oxygen side. So the hydrogen atom has strong positive charge and oxygen side has strong negative charge. In this way, the permanent dipoles are produced on the water molecule. Now, when another water molecule came near to such a molecule, then what happens is that the hydrogen side of that will create a bond with the oxygen side of previous, and in this way a single water molecule, the hydrogen side, two hydrogen sides of a single water molecule creates bonds with the oxygen sides of the two other water molecules, where oxygen sides are negative charge, negative side of the dipole, and hydrogen sides are the positive sides of the dipole. So between positive pole of one molecule and negative pole of another molecule, the bond is strong bond is formed, and that is to between the molecules which has hydrogen atom. So it is known as hydrogen bond. Okay. Now let us have the properties of hydrogen bond. Let us study the properties of hydrogen bond. See, the significance is to the hydrogen atom, since it is the hydrogen side is without the shielding of the electron, so it is a strong positive charge, pure positive charge. Okay, and when positively charged hydrogen atom interact with the negative end of the other molecule, it is a very strong interaction, since it is a pure positive charge. Okay, it is towards hydrogen side, toward hydrogen atom side. It is a strong interaction between hydrogen atom, positive side of the hydrogen atom, and negative end of the other molecules compared to any other positively charged atoms, because any other than hydrogen atom will have a shielding of electron. Okay, so this is the another important. Therefore, what happens is that hydrogen bond that has been formed, okay, between the positive pole of hydrogen atom and negative pole of highly electronegative atom such as oxygen, okay, it is a very strong. So hydrogen bonds are stronger than the other dipole bonds. For example, we have studied that van der Waals bond, which is again a dipole induced dipole bond, but it is very weaker. And why that we have studied? Because here it is a hydrogen atom. Okay, so hydrogen bonds are stronger than the dipole bonds, and it is simply due to the strong interaction between positive side of hydrogen atom and negative side of the electronegative atom. The materials having hydrogen bonding thus possess high melting and boiling point as compared to molecular solids. Molecular solids are the solids possessing van der Waals bonds, and since the hydrogen bond is strong, so materials with hydrogen bonding possess high melting and boiling point as compared to molecular solids. Important role of hydrogen bond is in the formation of ice and water. Okay, it is due to hydrogen bond that ice will freeze at 0 degree centigrade and it will boil at 100 degree centigrade. Now, if we consider that there is no hydrogen atom in the formation of water molecule, or in the absence of hydrogen atom, what happens? That water will boil at minus 80 degree centigrade rather than 100 degree centigrade. So, this important difference is due to the special significance of hydrogen atom. Now, in case of molecular bond, that is van der Waals bond, we have seen that the binding energy is simply 0.1 electron volt. Now, what about binding energy here in the hydrogen atom? It is 0.5 electron volt per bond. For example, it is water or ice. Okay, so 5 times, so it is a very stronger bond. Since hydrogen bond is formed between oppositely charged ends of two permanent dipoles, of course it is directional in nature. Let us look at this figure. So you will find the directionality that here it is a water molecule and these are the two hydrogen atoms. So the hydrogen atoms will create a hydrogen bond with the other water molecule when the oxygen side, that is a negative pole of that water molecule, is towards this hydrogen, and similarly here also. So this is a directional in character. Okay, so with this we conclude today's lecture. Thank you.